Hello everyone, myself Shashank and I am from Sri Venkateswara College of Engineering, Bangalore. Today's my topic is polar coordinates. The non-unequals of the polar from the major difference between the rectangular and the polar system. Step employed in the solution obtained in the rectangular x and y equations when applied to the r and theta polar equations have to be implemented in the light of the polar geometry. An example, interpret and draw the graph of each of the following polar equation. Convert each equation into the corresponding rectangular form. R is equals to K. The polar equation states that the distance from the R from the origin to the point A is the constant. This is a circle of the radius K centered at 0, 0. Definition of polar coordinates. Polar coordinates provides a method to represent the position of the point in a plane using its distance r from the origin and the angle theta. It forms with the positive x-axis. Conversion between polar and Cartesian coordinates. Learn how to convert between polar and Cartesian coordinates to seamlessly switch between the different coordinate system. Graphing polar coordinates. Unlock the secret of the graph polar coordinates to create beautiful and complex pattern. Application of polar coordinates. Witness the broad range of application where polar coordinates prove to be a powerful tools for physics to the engineers, astronomers to image processing, explore real world of engineering where this coordinate system shines. Advantages and disadvantages of using polar coordinates. Uncover the strengths and weaknesses of the polar coordinates in the different contexts. Understand when they outperform Cartesian coordinates and where their limitations may pose challenges. Gain insights into the optimal usage. Conversion between Cartesian and polar coordinates. Cartesian to polar. Discover the formula from converting Cartesian coordinate to the polar coordinate. Polar to Cartesian coordinates. Learn how to convert polar coordinates to Cartesian coordinates using clear step-by-step instructions. Polar coordinates time limits. In 17th century, the concept of polar coordinates was introduced by Isaac Newton and Boxer. In 18th century, Leonard Euclid developed the modern notation for polar coordinates. In 19th century, Auguste Mobius made significant contributions to polar geometry. Polar coordinates. Explore the application of calculus in the realm of the polar coordinates, including finding slope, concavity, and r length of polar curves. Real world applications of polar coordinates. Discover how polar coordinates are utilized in various fields such as physics, engineering, and navigation, enabling Precise calculations and measurements. Steps for finding other polar coordinates. Subtract 360 or 2 pi to get a negative angle. Second one. Add 180 or pi to change the r to negative. Halfway around the circle to be on the other side of the polar graph. Add or subtract 360 or pi to find the other angle. Steps for converting from rectangular to the polar coordinates. First point. Always plot the point x, y first. To find r square is equals to x square plus y square. Third point. To find theta, remember that we only know x and y. Therefore, the trig value that we can use involve only x and y. Tangent. Tan theta is equals to y by x. Tan theta is equals to tan inverse y by x. Polar equation of circle. The equation r is equals to a is a circle of a radius mod a centered at the pole. Next point. The equation r is equals to a cos theta is circle of a radius modulus a by passing through the poles and with the center on theta is equals to 0 or theta is equals to pi. The equation r is equals to a sin theta is a circle of a radius a by 2 passing through the pole and with the center on theta is equals to pi by 2 or theta is equals to 3 pi by 2. Tangents to polar curves. Give a polar curve r is equals to f of theta. The Cartesian coordinates of the point on the curve are x is equals to r cos theta is equals to f of theta cos theta, y is equals to r sin theta is equals to f of theta sin theta. Hence, dy by dx is equals to dy by d theta divided by dx by d theta is equals to dr by d theta sin theta plus r cos theta divided by dr by d theta cos theta minus r sin theta. Thank you.